Thank you very much. So how many of you have explored Clojure already? Great, because this talk is going to be more about walking through some of the ideas of Clojure and some of the basics of Clojure, kind of in the nature of solving a problem. I know that when I pick up a new programming language, I need a problem to solve. I can read a book and I can explore, but I need something I can wrap my head around. I need a purpose. And so the point of this talk is to introduce a purpose and try to solve a problem with Clojure. And along the way, we're going to learn some stuff. So for those of you who haven't really heard the Clojure pitch, we'll start there. Right? Clojure is built on top of a really solid foundation. It's about catering to a platform, catering to a host. The JVM is a wonderful platform. It has some idiosyncrasies, it has some problems, but there have been billions of dollars invested, and it's a really, really nice place to land a language. There are a set of interoperability concerns, obviously, with pushing a language on top of another virtual machine. Clojure solves that problem, full interop with the Java underpinnings, right? It's wonderful to have this library, this whole world of libraries that comes with the JVM, right? A lot of issues of Lisps in the past have been having to recreate the world every single time because this Lisp was different than another Lisp, and it kept kind of falling short. But Clojure right away had all the Java libraries to support it. And over time, those have been kind of replaced with other things, but there wasn't that big hurdle to get started. And I think one of the big pieces is that Clojure chose to go a different way. Everything's immutable by default. This helps a lot of problems, right? There are other concurrency primitives, things like that, that Clojure has provided. We're not going to talk about those today. Not everybody has to solve that problem. The most important thing to take away, though, is immutable by default. That actually solves a lot of problems just on its own. And when you have to have mutation, which we all do, it's well controlled. It makes you think about your mutation, and it makes those programs just a bit better by making you think about what you're going to do before you do it. And like a lot of other languages we've seen at this conference, or we're going to see at this conference, it's mostly functional. There are languages like Haskell that are more the purely functional. Because of Clojure's underpinnings of the JVM, it's a little bit difficult to act purely functional. But at the same time, we've chosen to be a little bit more pragmatic about how you interact with the system and not have to kind of force you to wrap that like some of the purely functional languages do. I think it actually is a great choice, but it can get in the way at times. And so trying to get a little bit more productivity out of that end when you don't quite understand those surroundings. And most important, and my favorite thing, is that it actually brings all the power and expressiveness of Lisp. Lisp is a wonderful, wonderful language. It's been around for a very long time. And it gives you so much power to create your own world, right? It really is whatever you want it to be, right? The minimal syntax, the composition of the language gives you the ability to express your solution any way you would like. I think there's also downsides to that. I think if you ask Eric Meyer about that, he has different ideas. But I think if you're really into that idea, there's no better language than Lisp to provide that. So today we're going to cover the basics of Clojure. Defining functions, that kind of stuff. If you've never seen it before, this will be, we won't leave you in the dust. Clojure's test framework, the built-in test framework called Clojure.test. Java interop, polymorphism, macros, and Leiningen. Leiningen being the build tool, kind of wrapper around Maven. But without further ado, we have a problem to solve. We have to figure out, and we're going to do something, what problem are we going to solve? Today, it's going to be Redis. We're actually going to write an adapter or library to interact with Redis. In Eric's keynote, he mentioned Redis. It's a wonderful little tool. It's storing data structures. Really, it's kind of propositioned as a key value store, but it's really about storing data structures. I have a data structure, I want to put it somewhere, and then I want to get it back out. That's what Redis is. And I'm sure you're all thinking that surely somebody has solved this problem already for Clojure, and indeed they have, right? This isn't the point. The point is, it's a really simple idea. I have strings, I put values inside of keys, and I get them back out. It's a very easy, very bite-sized problem that you can chew off without too much issue. It doesn't have a big domain you have to kind of wrap your head around before you get started. So I like this as an example. Now, these other libraries that I've listed are for your reference later. They all implement the entirety of the Redis interface. We're going to build a small piece of it today. But it's going to be surprisingly kind of well covered. So when we get started, we have a few things we need to do. When I start a project, I like to kind of make my own little world. That way I can operate there without having to worry about what's installed where and what's going on. So I'm going to create a new folder. I'm going to make a script directory, and we'll see what goes in there in a minute. Line new is part of Leiningen. So if we're looking at that, that's the packaging system of Clojure creating me a new project. Inside of that, we're going to put a little shell script that's going to go ahead and download Redis. It's going to deal with the fact that we can't choose between wget and curl on our operating systems, and then it's going to build Redis for us. Once we're done, we'll go ahead and take a copy of the config. We'll copy the Redis binaries over. We're going to have a nice little isolated world we can work in. I like to do this with my projects. That way I don't have to think about what's going on. And if you have a different version of Redis installed in your system, who cares? This will focus on just a certain version. And you can change that too. So when we're done, we actually get a little project like this, right? Leiningen provides the README. We've created the bin and config directories. Project CLJs we'll get to in a minute, provided by Leiningen. Also script we created, and then it creates two folders, source and test, which our code will live, and then all the stuff that gets built outside of Redis. So Leiningen is a wonderful tool. One of the things that was obviously painful right away in Clojure was how do we deal with dependency management? How do we do that in Java? We use things like Maven, right? How many of you like using Maven? Good. Oh, okay. We have one Maven fan. All right, good. So you can take this in and see how you feel later, right? Maven is pointy. It's all this XML, and it's confusing, and it's big, and you have to deal with this kind of living beast as your project grows. So Leiningen said, great, we're going to use the Maven for dependency management, and we're going to wrap it in something that makes sense. So this is what your POM looks like on Clojure. A definition of a project, it has a description, a URL. If you want to add a license, you can add that, and then you add your dependencies. You can have profiles and developer dependencies and things like that, but it's really just quite simple. It follows the same kind of organization ID and version number that Maven does. You don't really change that there. It acts just the same. But you have something that's much more easy to digest than the 50 lines of XML this takes to make our POM file. So great. Without further ado, we have a problem to solve. Again, so we're going to do little yak shaves throughout this talk to kind of introduce the concepts. But the first of this is the Redis Unified Protocol. On their website, they list a way to communicate with Redis. This is how this will work. It works pretty simple, right? So we start with a number of arguments, right? An asterisk and the number of arguments you're going to provide, followed by a character return line feed. We also have a $sign and then the number of bytes the following argument is going to have. So, or the first argument, character return line feed. The next is the argument data, followed by a character return line feed. And then we just kind of repeat this until we're done. So it's pretty simple. So it ends up looking something like this, right? Same example from above, using the set command in Redis. So asterisk 3, that's going to be 3 arguments. The first one has 3 bytes. It is set. The second one has 5 bytes, my key, 7 bytes, my value. And if we go through, we encode the string something like this, right? So when you see this here, this is what's going to be sent over the wire to Redis. Problem 1. So we need to make something that will produce this for us. So where do we start? What's the first thing I want to go do? If you're writing software and you have a problem, what do you do first? We're going to write a test first. Perfect. So, but in order to do that, we have to look at Clojure's test framework to figure out how we're going to solve that problem. So let's take an example function. Hello. Clojure syntax, for those of you who aren't familiar, defn defines a function named hello. There's an argument list here. The function body follows. In this case, this str function is going to take any number of arguments, and it's going to create me a string. So I'm going to have the string hello space, followed by the symbol name, followed by an exclamation point. It's going to take that and turn it into a readable result. So if I want to write a test for this and find out if it works, I pull in Clojure's test framework. I write def test, which will define a test. I give it a name. And then I ask it a question. Is this string equal to invoking hello and passing yow in? And so for those of you who also aren't familiar with Clojure's prefix notation or Lisp's prefix notation, the thing you're going to do comes first. The thing you're going to, so I'm asking equals and I'm passing it a set of arguments. Like I said here, str and a set of arguments. You'll see that throughout my code examples as we follow. So now now that we kind of understand how this works, let's take it and turn this protocol example, the thing we just did, into a test. So this is the test. We again make our test, def test. I added an extra little thing here, testing. It gives a little bit of context. So if our test fails, it'll tell us kind of what was going on when this failed, what we were testing when this failed. So then I take that string that I had from before, I just copy it in there. And I say, is it equal to invoking a function I haven't actually defined yet, command, passing the argument set, my key, and my value, right? These are the things that we're looking to do. So I'm going to create my little magic world here, and since we haven't written it yet, it's going to fail miserably. But we can go to an implementation and see how this is going to work. Now, this is quite simple. This is the implementation. This actually covers the entire Redis Unified Protocol. So we define a command. Something new here, right? We see name and then this little ampersand and args. Ampersand means there's a variable number of arguments that will follow. That's it. Now I'm going to define crlf just to be equal to /r/n. I'm going to use that in a bunch of places here, so I'm going to give it a name. I'm going to create a string. Remember, we already saw that. And I'm just going to go right down that spec like we had before. Star. I'm going to count the number of arguments that are passed in. I'm going to include by 1 because I have to account for the name. crlf, right? Next, we're going to have the number of bytes. So we'll count that name. The name is the first argument that's going to come in, crlf. We're going to uppercase the argument that's passed in. Redis likes to deal with uppercase commands. And the last thing we're going to do is we're going to take those arguments that were passed in, we're going to map across them, and we're going to apply this function here. fn is anonymous function syntax. That function takes one argument, the argument, and we're going to make a string, right? Just like we had here before, we'll create the number of bytes by counting the argument. We'll add a carriage return line feed, and we'll put the argument data after it. And finally, we'll follow with a carriage return line feed. Doing that, we run our tests, and that implements, or that passes this one test. We can write a lot more tests for this, and we will. But this actually defines the entire Redis Unified Protocol. This code that I just showed you could be a little bit cleaner, but I wanted to kind of go through each individual piece to make sure that we kind of, it was obvious what we were doing here. So, now that we have a way to talk to Redis, we have to actually do the communication. So in order to do the communication, we have to kind of talk via sockets. Redis operates on a TCP socket. We have to spend some data out to it. So I'm going to drop down to Java to do that. Java provides a library for working with sockets. It's part of the language. So in order to do that, we have to learn Java interop and Clojure first, right? So Java interop and Clojure is quite simple. You'll see something here that's kind of familiar to you, import. Import is exactly what you'd expect. However, what follows is just a little bit different. First, we're going to say I want to pull in the Java net package, and I want to pull in the socket class. Now, what you can do, you see the space here? We can just separate every single class from the Java net library that we want with spaces, and it will pull them all in. So it makes it a little bit easier to use than having to write java.net over and over and over and over again. And sure enough, it'll tell you I've imported it. If you want to construct a socket, there's this little dot at the end here. This little dot actually says, make me this thing. And if you want to actually give it some arguments follow, and all of a sudden we have a working socket. Now, obviously, Redis has to be running for this to work, but we have a working socket. We can bind that to symbol S, and then we can call things on it, right? Remember prefix notation. It actually works the same way with Java interop. We call the little dot, which denotes Java interop, and I'm going to call the set keep alive function on my socket, and I'm going to pass it the value true. And likewise, I'll get that value back out. So that's the kind of the basics of how Java interop works inside of Clojure. So now that we have that, we can actually kind of write our hello function to Redis. So we'll take and we'll do what we just did here, right? We're going to invoke our socket, and we're going to create a function, right? We haven't seen this little minus yet. This is private. Defn minus means private. So we're going to create a private function named socket with no arguments. We're going to create our socket here, but notice another thing here called do to. So remember in our previous example, we had, oops, wrong way. We had this little def s, and then we had to set keep alive on s to true. If s is a longer name, I'd have to type a lot. We don't need to type as much. We can actually use the do to macro here, and we'll pass it this thing, and what it will do is deconstruct these and add this socket as a second argument to all the functions that follow. So I don't have to type that over and over again. So it means I'm gonna assume this is my argument, my first argument to every single thing that follows, and just treat it like that. So it'll be a little bit less typing. And then we'll create our actual request command. So we'll feed it the command we want to pass in, which is that little string that we created with our command. With open is a nice little macro in Clojure that says anything I do here, I'll go ahead and ensure that it's closed on the other side. So we're going to open our stream, and then at the end of this, Clojure will just take care of cleaning up the resources and handling everything for us. So we don't have to do our finally blocks and all the other stuff to ensure that it's closed. So we'll create our socket, we'll create our in and out, and then we'll just write our command, we'll get the bytes and write it out to the stream. And then we'll print the results back. Now that's not going to be very useful yet. So we'll give it a try, right? We've got a nice little library shaping up right here. We're asking for a request, we're feeding it, we're asking for a command with set and the key foo and the value bar. And we see that we've got the data input stream back, which is useless to us. It tells us nothing. So we can actually go back to Redis, right? We can say, hey Redis, get me the foo key, and bar comes back out. So we know that we've done the right thing. We know that we sent the data out. We know that we're talking with Redis and it's actually working now. And in order to get the next phase of this, we're going to have to kind of dissect this in different ways. Redis responds differently based on the type of reply it has for you. So we're going to talk about polymorphism first because we're going to solve our problem with polymorphism. So in Clojure, there's it comes in different flavors. The idea is everything's built on top of the Java interfaces. So you have kind of polymorphism in Java kind of flows through. Now, we have other things like proxy and reify, which lets you implement interfaces on the fly. We also have things like protocols. We're not going to cover protocols today. I can actually give 4 talks on protocols, more class-based dispatch. What I want to talk about is arbitrary dispatch with multimethods. I'm going to create a function, and the result of calling that function is going to be the dispatch from a multimethod. It's actually quite cool. So here's how they work. So I create a multimethod called encounter. I feed it a function. It takes 2 arguments. And really what this is going to be kind of a map scenario. I'm going to pull the species out for both of them. So if I have a bunny and a lion that encounter each other, the bunny's going to run away. If a lion encounters a bunny, it's going to eat it. If a lion encounters a lion, they're going to fight, and we don't need Barry White to tell us what happens when 2 bunnies interact. So if we try that, we can just make sure that everything comes out the right way. We've had our arbitrary function, we know what happens, we test it out, and we see the right things come out. So that's kind of the general makeup of multi-methods in Clojure. Now the Redis response structure mirrors this in an interesting way. So this is, again, copied straight from the Redis documentation. It's great. If you want to look at a really well-documented open source project, Redis is one of them. It has a great little website, lets you try everything. Even the commands interface, when you're looking through the commands on the website, it actually gives you a place to try that command right on the page where it defines what it does. Really nice. But there's a commonality here, and we'll walk through it first, right? A single line reply starts with a plus. There's nothing else that follows, just one line. An error message has a minus. An integer reply has a colon. A bulk reply, which means there'll be several responses, has a $sign. And there's another thing that Redis defines called a multi-bulk response, which we're going to completely ignore for the purpose of this talk, that starts with an asterisk. Now there's a common piece here. What is that common piece? What is that thing that we're going to, I think I heard somebody say it. First byte, right? First byte is our common dispatch. We've just defined our kind of random dispatch here. Not really random, but we have an abstraction here. We dispatch on the first byte. The first byte will tell us what this is, and now we can magically make a multi-method that will handle our response based on the first byte that comes back from Redis. So, here's our multi-method. Again, def multi, and we call it response. We'll feed that data stream into it, and we'll pull the character of the first byte. That's our dispatch. Now we've set our dispatch, we say handle each one of those types, right? So if it's a minus, we'll read the line in. If it's a plus, we'll read the line in, right? These are both single line replies. If it's a colon, remember that's going to be an integer response. So we'll read the line in and then convert it to a long. Now, one thing of note here, before I get into the thing you shouldn't do down here, is read line is actually deprecated on the data input stream in Java, if there are better ways of doing it. For the purpose of this talk, it was a little bit shorter and easier to throw in. If you're going to do this for real, just make sure you read the docs and use something that's a little bit more current. Now, the thing you shouldn't do. My bulk reply, I just read the line and throw it away, and then I read the other line, which is just cheating, right? I know that in some cases, this is going to return a lot more data than just 2 things. But for this talk, we're going to concentrate on the small keys and cheat. So it'll actually work for us for this implementation. And finally, when we get to the multi-bulk response, we just punt and say, hey, we don't support that quite yet. But that way we've handled the case and we don't have some weird little misunderstanding about what's really supported here. So this pulls together all the things that we'd need to parse that response. So if we go back and try it again, now we see data flow back, right? So we set the key foo to the value bar. It says, okay, no problem, which is the default response from Redis. Actually, if you read the Redis docs, it will always return okay no matter what. Evidently, it can't fail. So I don't know what the reason for that is, but that's what goes on. And then if we actually ask for the get command, we get the data back. So now we're talking back and forth. What's the next thing we do? What was the first thing we did? We wrote some tests. So let's write some more tests. We want to make sure that some of the basic operations are working, and so we want to exercise integer replies and the single line replies, things like that. Make sure our multi-method's actually functioning properly. So we define another test, our basic interaction test. So we test set then get. So we make sure that setting server name to Fido returns okay. We make sure that getting server name returns Fido. These examples are pulled right from the try Redis examples. Now, if we test incr, right, we do the request and we make sure that an actual numeric response comes back versus a string to make sure our multi-method's working properly and converting the values. Delete does the same thing. So we've actually tested everything but errors in this case. It's actually kind of hard to get errors back. You have to try really hard. Redis tries hard to kind of not return errors. So there's some interesting cases there. We run our tests. We make sure that everything's running. Our 2 tests containing all 5 assertions are running. Life is good. Now we have a really hard problem to solve. Actually, it's not that hard. It's the meat of our problem, right? We're communicating with Redis. We're getting responses back. We know what we're doing. But now we actually have to implement all those Redis commands. How many of you know how many commands are implemented in Redis? Guesses. Sorry? A million, not quite. A little bit lower. 8, higher. 199. It's really close, actually. So I'm going to use Clojure to tell me how many commands are in Redis. I tried looking at the source code, and it turns out that there is no one place in the Redis source code that tells you all the commands in Redis. There's a command table, a struct in there that gives you 137 of them, but then there are a few others that are composed of the others that aren't in that command table. So you can't get it. The only place, and I checked and even asked the creators of Redis where I could do this. I said the best place to do this is to go to GitHub. There's a little JSON file on their documentation site that lists all the commands out. That's where it'll give you all the commands. So in Clojure, I can pull on the JSON library here, and there's a function called readString. I can call slurp, and slurp will take data streams, right? It'll take a file, it'll take a website, whatever, and it'll just grab the data. Really useful. I will take the value of that and read string, so I'll turn the JSON into Clojure data structures, and then I'll map across those, and I'll call first. First is just going to be the argument name. Happens to be the first position. So if I count that, it's 144 things that come up back. 144 commands I have to implement in Redis. These are them. This is the whole thing. This is what happens when I called that. So there's a lot of stuff here. We have operations on sets and hashes. We have pub/sub. We have Lua script support. There's all kinds of stuff that happens here. The question really is, how do we deal with this? Redis, that JSON, actually gives us a lot of information we can use. And we're going to go back to this later. But again, it starts with the name, it has a summary. What's really interesting, it talks about the time complexity of each one. So you actually get a little bit more information about how, what the cost of this is. Right, it's this data structure, so I can add the complexity. And then the list of arguments. At the bottom here, you see multiple true, which means this will be a variable argument function or a variable argument command. When it was added to Redis, and then what group it belongs to. So how do we do this? What are we going to do here? Do we write 144 functions? How many of you think we write 144 functions? Somebody, I mean, it's actually not that hard, right? And we could probably generate a bunch. I don't know. Okay, so nobody thinks we generated. Great. Of course not, right? We abstract this. We have Lisp. We have wonderful power of Lisp. Let's just use it. That's what we're here for. So I want you to consider the following DSL. And this is where this whole thing just gets a lot more fun. So consider the DSL, def commands. We have a thing called set, and we have some arguments, a key and a value. Get takes a key, incr takes a key, delete takes a key and any number of keys, right? This is not valid Clojure. It will not do anything. But we can make it do something, right? Because in Lisp, in Clojure like in any Lisp, there's a macro system. We have macros so we can make this work. we have the ability to extend our compiler and make whatever language you want out of it, which is why I love Lisp. So you can essentially extend the compiler, right? It's yours to control. You have your nice little hooks in here via the macro system. But there's something very important to remember, and that is the first rule of Macro Club. What do you all suppose the first rule of Macro Club is? Sorry? Don't write macros. What do you suppose the second rule of Macro Club is? Don't write macros. This is a really bad habit. Even Paul Graham said so, right? One of the most prominent advocates of Lisp said, when you can avoid it, when it's not the right thing to do, don't just write macros. How many of you are Ruby programmers? How many of you, when you learned metaprogramming in Ruby, just went, that's awesome, and I'm going to go do that a whole bunch? I did. You can raise your hand, it's okay. How many of you, when you did that, looked at your code like a few months later and went, what the hell was I thinking? This is just crazy, right? This happens, right? The same thing will happen to you with macros and Clojure. But just remember, kind of yank yourself back in. Macros aren't necessary except for when they're necessary, which is a really confusing statement. But the end result is use your head. Think. Now, to learn about how to write macros, I guess that's the next step, right? We need to figure out how we're going to write macros to solve this problem. So I want to show you some examples, simple examples of macros in Clojure. Now, before I get into this, how many of you are web programmers? How many of you have done a HTML templating of any kind? Right? We've all done this, right? That's what this is. Macros in Lisp are just HTML templates, except for their code instead. Right? Don't think of it as this wonderful magical unicorn pony that makes beer machines out of gumball machines. Right? It's just templates. That's all it is. And what you want to think of when you're writing a macro is, I have a template for code, and I have a thing I want it to look like. So I want to design something that will spit out the code I would want to see. Now, def macro is how it works. You give it a name and some arguments. This little backtick here, right? It says syntax quote. Don't actually evaluate this yet. And then return this expression. If not, and then we have this little tilde here. This means actually evaluate this. So replace the value. And then again for A and B. So the usage here, the thing we're going to define, this is what you should do first, is define the usage of your macro. Unless false, this line will print, this line will not. And there's this wonderful tool in Clojure called macro expand. The compiler uses this, so why shouldn't you? You have full access to this. We can expand this macro. We give it the quoted form. This little single tick is another quote. Not quite a syntax quote, but a quote. There's a slight difference we're not going to get into today. Unless false, right? Exactly what we did here, the use case. And then it will return what the macro expands to, which is exactly what we, figured it would do. So if, not, and then in this case, we pass it in false, so it passes that predicate straight through, and then tilde A and tilde B evaluate straight to what they were, right? It is expanded out to its own form. So now we can bring that DSL that we just had, the def commands DSL, we'll just go ahead and write some macros. We're going to write 2 to make this work. So the first one, def command, the single thing, right? It takes a name and it takes some parameters, right? Oops, I just pushed a whole bunch of weird buttons. Come on. Sorry about that. Okay, so we have our name and we have params. Params or parameters, this little function I don't have defined here, all it does is split apart those arguments if we have a var args and kind of make some sense out of them. Not important for this thing. What's really important here is I'm going to create functions. I'm going to create a function for every single one of those Redis commands. Now, so again, syntax quote, defn, the name, right? So tilde name, we're going to get a symbol passed in, we'll pass it straight through. The params, we'll pass the params straight through, because that's going to be the right Clojure signature. Remember, I mimicked Clojure's argument syntax right alongside of this macro. And then we're going to take, again, call command, tilde, stir, com, right? It's going to turn that into a string, right? We're getting past the symbol, we need a string to pass into our argument. And then this other little thing we haven't seen yet, tilde at, is called unquote splice. This is splat args. That's all it is. So take that list and turn it into just a bunch of things as arguments. And so what we're doing is taking all of these, we're applying command and its arguments to everything that comes in. Now, we can just go ahead and take a look at that. Just like we had the other one, we can macro expand this, right? So macro expand 1, def command, set key value. It defines a function with arguments key and value. It calls apply, command, set, key value, and this nil is left over from the parameter splicing. It gets dropped anyways. We need to test the variable argument case too, right? If we have additional var args, we want to make sure those are applied the same way. So we macro expand it, we have the right signature here, and out comes the function. Cool. Now we can define our functions as single arguments, but we don't have the ability to define the whole thing. The def commands doesn't exist yet. So we'll go there. We write our macro def commands. It takes a list of commands. Remember, that's what it was. So again, syntax quote. Macro can only take it can only do one thing. It takes a single expression. The reason why we have this def commands is we need to take the single expression of the list and turn it into all the things. So this is really do all the commands. And that's what this is, right? So we quote it, we call do, we unquote splice, right, across all the things. So all the commands. We map across the commands. We have an anonymous function for the command. Now we've unquoted, right? So now we have to quote one more time to call the def command macro so it evaluates the right way. And again, we unquote splice, we feed those arguments back in. And this is our def commands macro. One line of code, really. But it's a very powerful line of code. Because when we take a look, let's take two commands, set and delete, or del. Those are two of the things we define in our initial DSL. It calls do, and then it expands out to that piece. Now, macro expand 1, it keeps saying the -1, -1, -1. That's one level of macro expansion. This goes all the way down. And there's a way to find that out. Clojure.walk has a thing called macro expand all. And so if you do that, on the same thing I just passed in, you'll see what the compiler eventually resolves this code to, which is the same do we had before. But then you notice you don't see a def-n, actually you don't see the def command, but you don't even see def-n anymore. We've gone all the way down. Def-n was a macro. Def-n is a macro that expands to def, and then a name, and then the internal function syntax, and off we go. But you can see what the compiler gets all the way down at the very end. So you can see that your macro works really how you expected it to. So we have some stuff here. We've got kind of the basics we need. We need to clean this up. We're going to make this kind of a usable library. The things I haven't showed you is this namespace declaration, what we pulled in, right? The first thing here, refer Clojure, says, I want to take a look at the Clojure namespace, and I want to exclude set and get. Set and get are the functions defined in Clojure. And if we define those same functions, Clojure's going to go, hey, that's not cool. I already defined those things. Don't do that. It's going to define them anyways, and it's going to stomp on expectations. So in this case, we're saying, in this namespace, I don't care about set and get. I don't use them. I want to define my own. I'm going to require the Clojure string library. That's what I use to uppercase the name. I'm going to import the socket library from Java. And I'm going to take an buffered input stream and data input stream. Those are those things I use to make my request on the socket. Remember, it's just the top level package followed by class namespace, class name, etc. And it will pull it all in for you. And there's no star. Star is evil. There is no import foo.blah.star. We all know how bad that is. We just say no. What's that? We could write it. We could write it. We don't want to. That's not cool. So, we can take our library, we'll require it as Redis. Now, the reason we're doing this, the reason we're using require over use will take that namespace, the Redis namespace, and pull it into the current namespace. So if we do that, we'll have to use refer Clojure, exclude all of the Clojure commands we're overriding in every single namespace we use it for. So we don't do that. We require it, which makes it available to us, and we give it an alias called Redis. So when we do this, we'll never kind of trample over the current namespace we're in. That'll give us this final output, right? We'll call Redis request, we'll call Redis set on foo and bar, and then the things we've already seen that work. So, we have a good start here. We've actually created a library to interact with Redis, actually a large majority of Redis. This will work for at least 80% of Redis, in under 80 lines of code. Now, I'm not counting the the def commands thing we're going to do that spits out all the stuff, right? That's going to be at least 144 lines of code. So obviously that doesn't make any sense, and that's a lie. But this is far from finished, right? We didn't implement the multi-bulk replies. We punted on any bulk reply that contains more than 2 lines. There's a bunch of stuff that has to happen here. We haven't explained how to pass arguments into the connection. What if you want, other than localhost and port 6379? What if you want additional options? What do you have a password? We haven't done any of that yet. So there's lots to do, but there's one more thing I want to show you. And this is where we go off the rocker just a little bit and have a lot of fun. And this kind of is on that blurry line of the first rule and second rule of Macro Club, but it's fun anyways. So I want to automate these commands. Remember we had that JSON file with all the commands? I'm going to take and do this over again. I'm going to pull off that map first from it. I'm not going to get all the commands. And I'm going to define that to a symbol, and I'm going to print out the first one. So this is what it looks like in Clojure data structures. It has, the first position is zrem, which is the name, and then it has a bunch of stuff. It's basically a map, right? It has a summary and a complexity and some arguments, which is another list of things, the since and the group, right? This is all the data parsed into Clojure data structures. So what do I do with that? What do you suppose the logical step here is? Now that we have this data, we know how to write macros, what do we do? Come on, what do? We write a macro. So this is really ugly imperative code. But in the purpose of, or the spirit of this, we're going to write a macro. We're going to take the first thing that was passed into us and we're going to eval it. The reason being is we're going to actually pass it Clojure forms, not data. We also want to eval that and get the real data out of it. Second thing we're going to do is lowercase it, because we're going to pass it into our name. The second, remember this, there's first and second on that list, right? The first is the name of the command, second is all the other stuff. I'm going to define that as something so I don't have to keep calling second command over and over and over again. I'm going to create a doc string for my function. That's going to be a combination of the summary and the complexity with a new line in between. I'm going to pull my arguments out. So I'm going to map across the arguments, what I'm going to say data arguments gives you those back. I'm going to map across that. This is new stuff for you as well, right? The pound or the sharp is anonymous function syntax. It's short form anonymous function syntax. So I'm adding a little anonymous function in here that says percent sign is the thing, right? For each of these things, this is the one thing I'm doing. I'm asking for the name inside of it. And these are all strings back, but my arguments have to be symbols. So I'm going to apply symbol to all of those things, and I'm going to return a vector, right? Because that argument form is a vector. So I want to know whether or not it's a variable argument function. Again, I could do this all in one step probably. I'm just doing it, I'm separating it out kind of for demonstration purposes. I'm going to ask if any of these things have the key multiple in them. I'll know that this is a varargs function. With that, right, I'm not actually using the varargs, but we'll talk about why in a minute. Mostly because I'm lazy and it wouldn't all fit on the same page. But we'll take the same thing we did last time. We'll define a function. We'll call symbol on the name because we need to make sure we have a symbol there. Now we'll feed in the doc string and the arguments, and we'll do the same thing we did last time by applying command to the name of the arguments. Now, we could take this a lot further. I haven't used the varargs yet to figure out what the argument should be. And there's this other metadata, right? Since and group. They're here, they're useful, but we haven't done anything with them yet. We can take this, and in Clojure there's this concept of metadata. So a function can have metadata, a var can have metadata. You can say there are certain things about this that are orthogonal to this, but also very useful. So in that vein, we could actually say since and group are metadata. So we can say, hey, give me all the Redis commands that were implemented in 2.6, and out comes a list of that if we add the metadata. Same with the group. Let's, for instance, say that you wanted to know everything that operated on a set. All right, just ask me for the metadata for all the functions that are applied to sets, and out they come. What if you wanted your library to restrict the use of commands after a certain version of Redis? Because let's say you're running Redis 2.2, you don't want it to run commands that were defined in Redis 2.4 and 2.6 because they won't work. You can make sure that the version of Redis you're running is only calling the right pieces, right? Don't call things that don't exist, just fail. So you can use this metadata for really cool purposes. Let's try it. To show you that I have nothing up my sleeve, I have a blank REPL. I have the function zrem, or the symbol zrem. I'm going to ask for it, right? This little thing, the sharp quote, says get me the var. Just find me the var and give me the value. And it's going to say I don't have that. It doesn't exist. So define command is the name of my macro we just wrote. We're going to pass it in the first from com list, right? Remember we pulled all those arguments back. And then it's going to say that I defined a symbol called zrem inside the user namespace. If I ask for that back, it'll resolve. So right, this is, oops, working again. Oh no, I gave away my answer. So we know that things resolve now, right? So the next step is, what happens? Let's call doc on that function. Now we have a function defined with the right arguments and the doc string. Remember, we have that doc string that was there. So now our macro is transformed into something useful. So when we do this, we want to provide an interface for consumption that makes sense. A bunch of stuff without doc strings doesn't define you what it does. This gives you Redis's definition of what it does. There isn't any better definition than the Redis definition. Perfect. So now if we call it, out comes the right response. So we've used Clojure macros to take a bunch of data in and turn it into functions. All we have to do to make this work is just take that file in again, map across it, and call def command or define command. And now we have the entire Redis stack implemented command-wise in just the one macro. So we don't even have to define those 144 functions, or we don't have to have that def commands. We get that little last macro we wrote and throw it away. We can actually replace that whole thing, all 145 lines, with just that one macro. So now we have command, request, and a macro to define the whole thing. We wrote 3 functions, and we defined basically, or actually, I'm sorry, 4 functions for the socket. We defined the entire Redis protocol. That is very, very powerful abstraction. Some might call it going too far. I call it very powerful abstraction. Again, this is far from finished, right? We never addressed all of the last bits of things that I was talking about, right? We've kind of ignored a lot of things. But that's where you come in, right? Now you get to finish them. I've put all this code online. Play with it. Write better code than I did, because some of my examples are really imperative and gross, and you could make much better functional examples. So the idea is, here's a place to start. If you were looking for a place to wrap your head around Clojure, if you wanted to explore something but didn't know where to start, like I said, I wanted that problem to solve, right? There's lots of books, there's lots of tutorials, but until you have something you can tie yourself to, it's hard to get started. Here you go. I've just given you a place to get started. Redis is a pretty cool thing to interact with. Now you can just explore, right? You'll have to explore everything. You'll have to explore testing. You'll have to explore macros. You'll have to explore polymorphism. You have to finish the implementation, right? This is a great place to start. And so I put those online. I put them under my GitHub account. github.com/abedra/yao2012 is this talk. Like the slides are in PDF form are in there, as well as all the code. I'll leave this up for a little while so you can take pictures or write it down. GitHub.com/abedra/accession is actually the library I wrote for Redis in Clojure. So if you want to see a more complete example, it actually is fully documented. I try to do kind of the more literate style program there. And it actually exports its own docs and a nice little doco style thing. Redis.io is the Redis website. Clojure.org, if you want to get started in Clojure, it's a wonderful thing. The website has a bunch of stuff. ClojureDocs.org gives you a lot more examples of how to use the functions. I didn't put that there. And if you wanted a book to get started, I'll have a shameless self-promotion. I wrote Programming Clojure with Stuart Halloway. It was published in April, so it's still very current. That is a great intro book. There are other books like The Joy of Clojure, which are wonderful books after you kind of explore Clojure to really kind of dive in and get the most out of the language. But if you want to start somewhere, this is a great place to start. And on that note, we have 15-ish minutes, actually about 10-ish minutes for questions. So fire away. Are you up here?
Questions?
Over here.
Thanks. What sort of tools support do you recommend for Clojure? Like what sort of IDE do you use? What's popular? What works? What doesn't work?
Great. Tooling support. That's a good question. There are, I think almost every major IDE has support. So Eclipse has, I think, the best of the IDEs. It has the best support called counterclockwise. In IntelliJ, there's Clojure. There's something in NetBeans that I'm not sure what the status of it is anymore. I use Emacs, so I'm useless when it comes to explaining how the IDEs work. Of course, very good Emacs support. It is a Lisp. That's what Emacs does well. There's great Vim support. Really, really nice Vim support, actually. I think it's probably the second best out of all of them. Sublime Text, TextMate, those editors have additional support. It's really not, it's mostly syntax highlighting. There's a new IDE coming out called Lighttable. Lighttable is built in Clojure, and actually Clojure is one of the first languages that it supports. It's actually built all on the idea of the inventing on principle talk. Bet Victor, right? It's the idea of the fully interactive environment. It's really cool. But that's kind of coming along. It's not quite out yet. I guess there's some betas out right now, but it's kind of in progress, in development. But otherwise, I think whatever environment you're in, there's something to get you started. You may or may not like it. You may not feel right. You may end up switching, but pretty much every one of the environments has something for you. So if you want to get started, don't let that get in your way. You're good to go.
Hi, in your example code, you were sending Clojure variables to the Redis server as values. What types are they? Do they just support strings? Is there some way of handling it? Like, is there a type class, or how would you approach that in Clojure?
Yeah, so in this case, I was just sending strings. If I was going to get that data back, if I sent Clojure data in, I'd call read string on the way back out and let the reader turn that back into Clojure forms. In this case, my wire protocol or my data protocol is just Clojure data structures. I love that about Clojure. Clojure script actually has a reader too, so in between the web server and the actual client, you can send Clojure data structures as well. The reader is very powerful. I prefer just to use the reader to evaluate. But yeah, that is most of what was happening. Is Clojure data structures are stored in Redis, then pulled back out. I could use an intermediate representation. I could store data a different way, but why bother, right? I have everything the way I want it and the way I consume it afterwards. So I skip that step. But you can choose to do it however you want it to. So, but no type around that. No type class around that.
I really would like to confuse at some point, sorry. Were you using this just purely educational example of how macros work, or were you saying this is a good candidate for where you might use the macro functionality?
Good question. So the question was, is this a purely educational example of how you might use macros, or is this actually a good use for macros? I think the first example, where we defined our kind of new language, our new DSL, I think that is a good place for macros. Where you do something a whole bunch of times, and it has a very common interface. I think that kind of metaprogramming style of macro expansion works really well. The second example, I don't know. That might get messy. That macro is going to get a lot longer when we've added the metadata and we add the variable argument parsing and all the other things. That macro might turn into something that's just too gnarly to deal with. And it might actually be a really bad piece of code.
The body was the same every time it suited spell, wasn't it?
I'm sorry?
The body of the macro ended up, the body of the method we had, the function we had every time was the same pretty much.
Very close, yeah. It will add additional pieces, right? Because of the doc strings and the variable argument parsing, the metadata. That stuff will all go there, but that macro will get bigger if you do the complete implementation. So you could end up with something that was a little bit unwieldy. For me, it's drawing that line between something that's consumable by other people and understandable, because Lisp macros tend to get really gnarly. And when you do that, you've done no good to anybody, right? You've implemented something that nobody can understand without a bunch of effort spent. So I think you have to be careful about how you are doing these things and make sure that what you're doing is syntactic abstraction and providing value with your abstraction, not providing confusion. So I think you need to just kind of balance that. And it's really just an opinion thing, right? This is my opinion and not fact at all. But I think, so I would say first example, yes. Second example, maybe, I don't know. Depending on where you get with it.
Next question over there, please. In your probably 20 slides ago, I think it was about your first macro called unless.
Yeah.
Where you negated the predicate on the on if.
Yeah.
I noticed that I assume that the only one of the two branches of the if will run. I think you had a print line on each side in the example.
Yeah, I did.
And I think it was a little the tilde to say to evaluate it.
Yeah, let me grab that quick.
All right, you do that. I'll just watch Paul run.
Perfect.
All right.
So.
So I'm just noticing the tilde on either side of the if there on the A and the B.
Yes.
Which is to say evaluate both the A and the B, right?
So basically evaluate them as in pull the symbol in. Replace this with the value that was passed in here.
Okay. So is the if implemented as a macro as well?
If is a special form in the language, right? So if is a language implementation. Everything built on top of Lisp. If later on. So in a Lisp, there's 7 special forms plus or minus. If is one of them. It's implemented inside the language.
And just to carry on that theme, is the idea of forcing evaluation with macros like that a common theme when you're using Clojure?
Yeah, I mean, basically, if you're going to write a macro, right, this is that way that provides you the kind of, template style programming, right? So in this case, if this was a web page, an HTML or markup, right? This would be, I have some HTML and this would be, replace this with calling a function or find me a value and stick it in there. And that's really all. It's just kind of templating.
Okay. So the built-in if will only execute one of those two branches, right?
Yeah, that's right. So it'll replace the predicate or this with the actual predicate. It'll negate it, and you'll have the consequence and the alternative. And so it'll become just a regular if statement, but it'll negate it.
Okay, cool. Thank you.
Yeah.
Anyone else?
Obviously, you use this in production at Groupon, but what would you say are some of what is the path to adopting something like Clojure in a commercial environment, do you think?
So I think any environment that has a very fully supported JVM operations team is a good place. You need to be able to run this in production. So if you don't have a JVM, if you don't have the JVM in production, figure that out first. If you have the JVM in production, you know how to monitor it, you know how to support it, you know how it acts in your production environment, great. Then worry about Clojure. If not, solve those problems first. The operation stuff is ultra important if you're going to put it into production. Know how to monitor it, know how to support it. After that, it's just JVM bytecode, right? Your stack traces are spitting out Java stack traces, for better or for worse. But that's the first goal, right? Make sure you can run it in production. At that point, it's find the problem that works for Clojure. Clojure is really good for solving some problems and not as good at solving others. So find the right tool for the job. If you're crunching giant sets of data, if you're doing some of the machine learning stuff, there's some great Clojure libraries. There's Incanter, a statistical package that kind of replaces R. If you're doing solving those kind of problems, Clojure's wonderful for that. Lisp in general was meant to solve those kind of problems. Start there, hit the home run, and after that, then it gets a little bit easier. It's a general purpose programming language, so you really can't use it for everything. But if you want to introduce it, if you want people to adopt it, find the big wins, find the home runs, and start there.
We have time for one more question.
Quick one.
The last one.
So if you've already got a fully Java application, can you just include bits of Clojure in it?
Yeah,
just to
certainly.
solve a particular problem? Or?
Certainly, yeah. I mean, they're just jars. You stuff them. You put them in just like you would any other jar. They expose interfaces to Java, so you can call them. I know people that will take and pull the Clojure jar in just to use the persistent data structures in Clojure from Java. They work just fine. Likewise, the interop works both ways. So you can call Clojure from Java. You can expose everything you need, and so you can write a small little piece that might be a great little target for Clojure and embed it in your program, just like you can with Scala or JRuby or Groovy or any of the other JVM languages. They all speak interfaces at the end, so you have that common way of talking with each other. So, thank you very much.